Hello and welcome to this video on the Lung Health Checks modelling tool. I'm Andy Wilson, Modelling and Analytics Lead at the Transformation Unit. I've developed this model to support the implementation of the Lung Health Checks across West Midlands Cancer Alliance. The purpose of today's video is to provide a brief run-through of how the model was constructed, the underlying code, the outputs of the model, and how the model can be accessed via the GitHub repository. To begin with, we're going to run through how to access the model. The repository is publicly available so that all the code required to build the model is easily accessible. The repository also contains an example of the input spreadsheet and the diagrams of the lung health checks pathway. To access a model, simply go to this URL at the top of the page. If you have a GitHub account, you can fork a copy of the repository, and there you can explore the code in more detail. Next, we're going to familiarise ourselves with the lung health checks pathway that we're modelling. This flow diagram represents how patients enter the model and flow across the different stages. The first is around determining the number of patients that are going to be screened. This uses information such as what our starting population is, the proportion of those that are 55 to 74 years old, whether they've smoked or not, and also including other things like those that we've already screened, those who we need to re-invite, and then thinking about what the uptake rate will be in that population, i.e. of all those that we invite, how many get in touch to say yes, they want to be part of the lung health checks pathway. At the next stage, patients will be then booked onto a lung health check where they can attend and they'll have the lung health check performed on them, or potentially they'll DNA, and in which case they might need to be re-invited, or potentially if they opt out, they will then go back into the pot who will be eligible for being invited in the future. From this information, we can then determine the number of lung health checks that are going to be performed on the population of people who attend. Once those lung health checks have been performed, some of those patients will be invited for a CT scan. Now, some of those will be positive, some of those will be negative. For those who have a negative lung health check, they might go into the group of patients who need to be re-invited in 2 years. For those who are positive, they can go on to have a CT scan, and in some cases, patients may be excluded. Now, as the pathway continues, patients may well have that CT scan, and there may be something that's concerning from malignancy, in which case the patients will have potentially additional diagnostics, may well then be confirmed to have lung cancer, and go on to have one of these potential treatments. They could also be followed up in the future as well at different time points, say at 3 months, at 12 months, or 24 months. By drawing out the pathway like this, we can explore all the possible routes that a patient could go down when they're invited to the screening. We can also then work out what all the relevant endpoints are and all the activities that we need to model. Additionally, this provides us with guidance on all the assumptions that we're going to need to include in our model. So for example, for all those patients who have a confirmed lung cancer, what proportion of them have surgery, the proportion having surgery with adjuvant chemotherapy, the proportion having SABR, and so on. This then gives us a basis to think about what are all the assumptions that we need to be capturing within the model, and which of those the user needs to input and be able to change depending on the specific scenario that they want to model. Whenever we're embarking on this type of modeling exercise, it's always really useful to map out what that pathway looks like visually, because then we can check it with stakeholders, with clinicians, to make sure there aren't any routes that are being ignored and that all possible endpoints are being considered. This pathway is available within the GitHub repository. If you navigate to the images folder, you can then see how some of these have been created as PNG or SVG files, but we have the raw LHC pathway that we've just viewed within draw.io. Now that we've done the work to understand what the pathway looks like, and we understand a bit more around the assumptions that we need to collect, we need to think about how we're going to get these into a model. Now, there's lots of different ways that this can be done. In our work with the West Midlands Cancer Alliance, they wanted an input solution where they could add these into an Excel spreadsheet, populate all the possible assumptions, save that, and that could be used to form the basis of the model. This is an example of what that spreadsheet looks like. We have a front page where people can put in the geography, for example, of the particular location that they're modeling. And as we've just seen on the pathway model, there's a separate tab that captures each of the possible assumptions going into the model across each of the 5 years. There is a separate tab for each stage of the pathway. So rather than just having one long list of all assumptions, these are neatly broken down. For example, the lung health checks, we have the specific assumptions that we want and need for that stage of the pathway. For example, what percentage of patients who are invited decide to opt out of receiving the screening at that stage? So we record that for year 1, year 2, and so on. We could also look at what proportion of patients who DNA the lung health check the first time are then subsequently rebooked. The user can then work their way through all of the assumptions contained within this input spreadsheet and change them dependent on the particular scenario that they want to model. Now that we have our list of assumptions and we populated them with the figures that we want to, we can then think about how these get loaded and used within the model. So to do that, we're going to go through the code that's been used to develop it. Now the model's been developed using R code, so we used RStudio when we were building it, and that's what I'm going to run through now. If you open the model within RStudio through cloning the GitHub repository, you can then explore how the model is constructed. So the code is stored within the SRC folder. This consists of a config folder, so that contains the themes for visualizations and reports. Load folder, this contains the scripts required to load those assumptions that we've input into the spreadsheet. The model folder, that contains all the code used to model each stage of the lung health pathway. The outputs folder contains scripts that produce an R Markdown report that details what the outputs of the models are and shows those both in tables and visually. The requirements folder lists all the required R packages that you need to run the model. And the visualization folder contains the code for producing the charts and tables that are used within the outputs. There's also a model pipeline file. This file can be used to just quickly run through the model within the R environment itself. To run the model locally within our R environment, we simply run the model pipeline R file. That in turn just calls a series of different scripts to run and process each stage of the model. Let's do that now. How long this model takes to run will depend on the number of trials that we want to run. At the moment in the model, this is default set to run for 100 trials. This can be changed within the input parameters file within the config folder. What this means is that the model will run 100 times. We then take the results of all of these 100 runs and summarize the expected activities at each stage of the pathway. We will come on to this in a little more detail when we look at the model outputs. Another way of running the model and the outputs together is to knit the model output R Markdown file. This is available in the outputs folder. This file will run the model in the same way that we've just seen, but render all of the charts and tables into an HTML report. Let's do that now. We simply click on the knit button. Once that's finished running, we'll now have a nice HTML output where we can explore the findings from the model in a bit more detail. This report contains the expected demand and activity for each stage of the pathway, summarizing what happens across each of those 100 model runs. For example, let's have a look at some of the additional diagnostics that we expect to take place in year 1. This table provides a summary of the average, so the median number of additional diagnostics that we'd see for those patients who have a concerning CT scan. But it also shows a range of possible outcomes, so both the 10th percentile and lower quartile, but also the upper quartile and the 90th percentile. This provides us with a view of what we expect to typically happen, but also a range of possible outcomes, and therefore a range of capacity that we need to consider. For example, for EBUS, the median number of additional tests that we need to undertake would be 27, but we need 34 to cover 90% of all possible outcomes. This gives us an idea of the range of possible outcomes that our model will produce. This data is also shown using a histogram, so we can see the range of possible outcomes from our model. We can explore further each of those different stages by clicking through the tabs, so for example for confirmed malignancies and for different treatment modalities in year 1. There is more detail as well at the start of the report, covering a bit of background to what discrete event simulation is, a review of the assumptions that we've used within the model, so those that were loaded in as part of that spreadsheet, and also the pathway itself. So if we want to explore the pathway again in a bit more detail and understand some of that flow, we can see it. If you're interested in more detail of how the model works at each stage, we can look at the individual model scripts. So if we go back into our studio and navigate into our model folder. The model folder is organized in two ways. There's folders for each of the years, and there's a folder containing the functions for each stage of the model. If we explore the functions first, this will help our understanding of how the model is built. There is a file that contains all the functionality required to model each of those stages within the pathway. For example, let's have a look at CT scan. We have a function that will take our input data frame. So these are the patients that we expect to go through and have a CT scan. We take our assumptions around the exclusion rate, our DNA rate, for those who DNA'd, the rebooked rate, how many positive CT scans we expect to see, and of those who are negative, how many require follow-up. This function will then take our input data frame, so this is all those patients who've made it to the point of having their initial CT, and then it will assign them or randomize them to each possible outcome, dependent on the assumptions that we've already set within the model at that stage. For example, at this point, we determine those patients who will be excluded from having a CT. So we randomize them, and then we compare that to the exclusion rate that we've set. Where that randomization or the random number that we generated is lower than the exclusion rate, flag those as being excluded. Those who aren't will continue on to the next stage. We will then randomize those patients to see if they're going to DNA, and so on. These functions are then called within each separate year of the model run. So for example, in our year one model, when we're looking at CTs, we'll call our CT function and we'll input the data and the assumptions from the previous stage of the model. The data and information that we get back will then inform the next stage. So once patients have then had the CT, we can then think about of those who require an initial treatment. This gives you the option of running models step by step. So if we run each of these within order, so we take our starting population, then go on to our lung health checks, CT, and so on, we can see how one group of patients are randomized to those outcomes, and then we take those of interest and move them on to the next stage of the pathway. You can see that as well for each year of the model. So the model runs over 5 years, so there's separate stages for each of those 5 years. But again, this isn't necessary, as you can just simply use the model pipeline, which will run all of those different model components in the right order, and then we can just see them and all their outputs individually. Obviously, this is quite a complex model with lots of different components, and this is just a quick run through, but there is documentation available that goes through guidance on how to run the model. So there is this markdown file that will summarize what we've discussed in the video, and detailing how you can make changes, for example, to the model assumptions. Also, the README contains the structure of the repository, which summarizes what's saved where, and contains the pathway itself for familiarization. It's important to remember that while some of the input assumptions can be changed, these are all based on what this pathway looks like. Therefore, you can't necessarily just take this model and run your own pathway with it. However, it would be possible to start amending the model scripts that we've just reviewed within our. For example, in the CT one, we could add in additional inputs, or we could create additional steps within this functionality if there was a change to what that pathway looked like. Thank you for watching this video. I hope that you found it useful. Please feel free to review the documentation and the code within the repository.